Welcome to the deep dive. Building complex AI applications with large language models, well, it can sometimes feel like peering into a black box.
Uh-huh.
You put data in, you get results out, but understanding all those little steps in between is just crucial, isn't it?
Oh, absolutely. Yeah.
Especially, when things go sideways or you're really trying to squeeze out more performance.
Exactly. And that's kind of the challenge we're tackling today. We're diving deep into LangSmith. It's a tool designed specifically to, well, shine a light on those inner workings.
Okay.
It gives developers the ability to trace, visualize, and, ultimately debug their AI workflows with much greater clarity.
So like getting a really detailed map of the AI's thinking.
Pretty much, yeah, a detailed understanding of its process.
Right. And the key to this visibility, the thing we're really zeroing in on today, is a feature called tracing.
Mm-hmm.
We've been digging through a technical article that really unpacks how LangSmith pulls this off. Okay, so let's unpack this. For someone maybe new to this idea, what exactly is tracing when we talk about AI apps?
Right. So tracing in LangSmith, in essence, it's about creating a detailed sort of chronological record of your code's execution,
What?
particularly the parts interacting with LLMs or, other AI bits.
Okay.
And the main tool LangSmith gives you for this is the @traceable decorator.
The @traceable decorator. Okay, sounds like a core piece of this.
Yeah.
How does that actually work? How do you use it?
It's actually surprisingly simple. You just apply this @traceable decorator directly to any Python function you want to keep an eye on.
Just slap it on top.
Pretty much. And whenever that decorated function runs, LangSmith automatically generates what it calls a run tree.
A run tree. Okay, that sounds interesting. What is that exactly?
Think of it like a hierarchical map of just that single function call.
Right.
The first time your decorated function gets called, that's the root of the tree. Then any other functions it calls, or maybe LLM interactions inside that function, they branch off like limbs on a tree.
Oh, okay.
So it gives you this really clear visual of the entire execution flow just for that one run.
That visual sounds super helpful for, untangling complex sequences.
Yeah.
What kind of information does this run tree actually capture?
Oh, it grabs a lot of critical stuff. It gets the exact inputs that went into the function.
Okay.
The function's name, obviously, and lots of execution details like timestamps, how long each step took, potentially resource use. And crucially, it also logs any errors that might pop up during the run. And of course, the final output or the result, the function returned.
So if my function hits a snag and throws an error, I can see exactly where and why right in that trace.
Precisely. And what's really neat is that all this data, it gets sent off to LangSmith in real time.
Real time. Wow. Does that slow things down?
Nope. That's the clever part. It uses a background process, like a separate thread, so it doesn't add any noticeable delay or overhead to your actual application.
Oh, that's huge. So you get the deep insights without the performance penalty.
Exactly. And that level of detail is just invaluable when you're trying to hunt down the root cause of some bug in a really complex system.
Okay, I need to see this in action. The article you mentioned, it had a Python code snippet, right? For a process transaction function. And it used the decorator.
That's the one. Yeah. This is a simple example. Simulates processing a financial transaction, takes a transaction in an amount.
Right.
And inside, it just randomly decides if the transaction works or fails. If it fails, it raises a standard value error. Pretty straightforward.
And applying the decorator, like the article showed, is literally just putting out traceable on the line before the def process transaction.
Yep, that's all it takes.
So walk me through what happens in LangSmith when we run this function, say, once successfully and then once when it fails.
Okay. So when process transaction runs successfully, LangSmith logs a trace. It captures the specific transaction ID and amount used, the function name, timestamps, and the successful result.
Got it.
Now, if it fails and that value error gets raised, LangSmith captures that exact error message. And it links it directly to that specific trace, along with the inputs that caused it. This is gold for debugging.
I can see that.
Instead of some generic error in a log file somewhere, you see. This transaction failed with these inputs, and here's the exact error, all tied together in LangSmith.
Right, having that direct link error function inputs all in one place in LangSmith. Yeah, that sounds like a massive time saver. Definitely beats grepping through logs.
You bet.
Now, the article also talked about adding metadata to these traces. What's the idea behind that?
Metadata is basically about adding extra layers of context. Think of it as attaching arbitrary little key value notes to a specific run.
Okay, like sticky notes for your traces.
Kind of, yeah. Any data that helps you understand what was going on in your app or its environment at that exact moment.
Can you give me some examples? Like what kind of metadata would actually be useful?
Sure. Maybe the application version number that generated the trace. That's a common one.
Okay, yeah.
Or the environment was this run in dev, staging, or prod.
Right.
You could also include custom stuff, like maybe a user ID if it's processing user requests, or perhaps specific config settings that were active. Anything relevant, really.
Okay, I can definitely see the value in that extra context. How does LangSmith then let you use that metadata once it's captured?
That's where it gets really powerful, especially in the LangSmith UI. It gives you great filtering and grouping options. So, for example, you could easily filter down to see only the failed transactions that happened in production, maybe only for version 1.2. Or you could group all the traces by a specific user ID to see everything that user did. It makes it much, much easier to spot patterns or understand the impact of a new deployment or isolate issues affecting certain users.
The article had another code bit, didn't it? A process order function.
Yeah.
Showing how to add metadata right in the decorator.
Exactly. Yeah, in that example, they pass a metadata dictionary right into the @traceable decorator itself.
Okay.
Something like metadata at version 1.2.3 environment production. So every single time that process order function runs, those 2 bits of info, the version and environment, automatically get attached to the trace in LangSmith.
So you could easily track if, say, version 1.2.4 suddenly starts causing more errors in prod just by filtering.
Precisely. It makes tracking the impact of changes really straightforward.
That makes total sense. Okay, shifting gears slightly, given we're talking LLM apps, the article specifically mentioned how LangSmith handles traces from chat models. What's special there?
Right. So LangSmith has some tailored handling for LLM traces. It's designed to give you a better, more useful visualization.
How so?
Well, because chat involves that back and forth, LangSmith kind of expects the inputs to be logged as a structured list of messages.
Okay.
And each message should ideally follow that OpenAI compatible format, a dictionary with a role like user, assistant, and then content with the actual text.
Right, the standard chat format. And what about the LLM's response? Does LangSmith expect specific formats there too?
Yeah, it's pretty flexible, but it understands the common ones. The main one is usually a dictionary with a choices key, which holds a list. And inside that list are dictionaries with a message key, which then has the actual message object with role and content.
The usual OpenAI structure.
Exactly. But it can also handle simpler formats, like if the dictionary just has a message key directly, or even just a tuple like assistant response text, or a flat dictionary with role and content. It tries to be smart about parsing it.
That flexibility is good. Less config hassle. Now, the article also mentioned extra metadata specific to LLMs, ELS provider, and ELS model name. Why track those?
Yeah, those are special ones LangSmith can use for Ritter analysis. ELS provider tells it who made the model, like OpenAI or Anthropic or Google.
Okay.
And ELS model name is the specific model, like GPT-4o Mini or Claude 3 Opus.
And the benefit?
Well, by having that info, LangSmith can accurately identify the model. And a big benefit is it can help calculate the costs associated with that call.
Cost tracking built in.
Yeah, gives you much more precise tracking of your LLM spend. But beyond cost, it's also great for comparing models, right? Maybe you're A/B testing GPT-4 versus Claude.
Right.
Or you want to see if performance issues correlate with the specific model version. Having that data tag is super useful.
That level of detail on cost and performance, model by model. Yeah, that's a big deal for teams trying to manage usage.
Yep.
Now, many people use frameworks like LangChain or LangGraph. How does LangSmith tracing fit in with those?
Oh, the integration there is really smooth and powerful.
Sure.
LangChain helps you build those complex LLM chains, right? Sequences of calls and logic. And LangGraph lets you visualize workflows as graphs. LangSmith's tracing is deeply integrated with both. So when you run your LangChain chains or your LangGraph workflows, basically every step inside them gets automatically traced.
Every single step, like LLM calls, tool uses, everything.
Yeah. All the LLM calls, interactions with other tools or functions in the chain. It all gets captured as part of a larger trace in LangSmith. This gives you that complete end-to-end view of these really complex AI systems. Makes it way easier to see the flow, find bottlenecks, figure out where something went wrong in the whole workflow.
It's not just tracing one function anymore. It's tracing the entire journey through the chain or graph.
Exactly. It scales up the observability significantly for those more sophisticated applications.
Okay, that is a big step up. Now, what if I have a chunk of code I want to trace, but it's not like a neat single function where I can just stick the @traceable decorator. Are there options for that?
Yes, absolutely. For cases where the decorator isn't quite right, LangSmith offers the trace context manager.
Context.
It lets you explicitly say, okay, trace everything inside this specific block of code. You wrap the code using Python's with statement.
So it's like drawing a box around a piece of code and saying, LangSmith, watch this bit.
That's a great way to put it. Yeah, exactly. When your code enters that with block, tracing starts. When it exits, tracing stops for that block. And within that context, you actually get more granular control. You can manually set the inputs, the outputs, add custom metadata right there in the code.
Oh, okay.
The article showed an example, right? A complex function where they use trace context just to trace summing a list of numbers.
Yeah, I remember that.
And they even use trace.set metadata inside the block to add details like the data size or the summation method used. So it's really flexible for those odd bits of code or when you need that fine-grained control during execution.
That does sound really handy for more complex logic or just specific critical sections. Okay, last key thing the article covered was conversational threads. This sounds vital for things like chatbots. Why is tracking conversations as threads so important?
Oh, it's absolutely crucial for chatbots or any conversational AI. You need to maintain the continuity, right? The context of the whole dialogue.
Yeah, you can't treat each message separately.
Exactly. You don't want each turn to be an isolated event. LangSmith's Threads feature lets you group all the related traces from a single conversation together. So you get this single, unified view of the entire interaction. Makes it so much easier to follow the flow, see how the LLM's replies change based on what came before, and debug issues that might span multiple back and forth.
So how do you actually link them? How do you tell LangSmith these 5 traces are all part of the same chat?
You do it using metadata again, actually. You include a specific metadata key with the unique value that identifies that conversation.
Okay, like a session ID.
Exactly. The article mentions common keys like sessionid, threaded, or conversationid. You pick one, generate a unique ID for each conversation. Usually a UUID is good.
Right.
And then you include that same key value pair in the metadata for every trace belonging to that specific chat.
Got it.
LangSmith sees that consistent ID and automatically groups those traces together in the UI as a single thread. Makes following the conversation history way, way easier.
It really is all about keeping that context clear across the whole interaction.
Okay, that seems to cover the main points from the article. It really sounds like LangSmith provides a pretty comprehensive toolkit for getting that deep visibility into LLM apps.
It really does, I think. You know, from the simple @traceable decorator for quick function tracing to the trace context for more control, the ability to enrich traces with metadata, the special handling for LLMs, the smooth integration with LangChain and LangGraph,
Yeah.
and then the threads feature for conversations. It all adds up. It gives developers that detailed view they really need to debug effectively, optimize performance, and just build more reliable and transparent AI systems.
Absolutely. Being able to finally, shine a light into those previously murky processes feels like a genuine game changer for building and, importantly, maintaining these complex AI applications.
Totally agree. So, as you're listening and thinking about your own AI projects, maybe mull this over. How could gaining this kind of detailed insight into your application's guts, its inner workings, how could that fundamentally change your development process? And maybe even improve the quality of what you built? What new possibilities for tweaking, for optimizing, for just understanding? What might that unlock for you?
Good question to ponder.
That's definitely your food for thought for this deep dive. Thanks for joining us.